Welcome to EEMS 230. In this video, we will explain the graphical user interface features of the die module in eFTC Explorer. The die module can be used for a variety of purposes, including comparison to die tracer experiments conducted in the field, and tracing of passive constituents in the water column, which can include decay and settling processes. The die module can also be used to simulate the age of water. Additionally, any number of die classes can be simulated, which can support more detailed evaluations of mixing between water from different sources. Let's get started. To begin using the die module, you can start by opening a model in eFTC Explorer and activating the die module. To begin setting up the die module, right-click on Die and click on Settings to open the die settings. In this form, EE allows the user to configure any number of die classes in the simulation. To start creating die classes, enter the desired number of die classes in the Number of Die Classes text box. The die parameter frame displays the parameters of each defined die class in the model. The ID field is used to name the die class and is useful to differentiate the purpose or function of each class. The function of each die class is determined by the type and subsequently defined parameters. There are three options for die type. A conservative die does not decay during the simulation. With this option, no values need to be entered for the decay rate, temperature adjustment coefficient, or settling velocity. Non-conservative die classes can use time-dependent decay rates, which are linear or exponential. These are referred to as zeroth or first-order decay rates in eFTC Explorer. Setting a negative value will lead to growth. The temperature adjustment coefficient, reference temperature, settling velocity, and the initial concentration of the die can be set for each class. Age of water allows the die to be used as a proxy for age. With this option, the zeroth order decay flag is set to -1, so that EE will calculate age. All other columns will be 0 in this option. The IC flag column allows the user to select which classes will be used with the values from the initial concentration column or the spatially varying concentration frame. If the IC flag box is checked for a die class, the value in the initial concentrations column will be used. If the IC flag box is unchecked, then the value shown for the class in the spatially varying initial conditions frame will be used. Setup of spatially varying initial conditions requires the user to first select the desired die class from the drop-down menu. Once that is done, click the Assign button to open the Apply Cell Properties via Polygon dialog for die. As with the setting of initial conditions for salinity and temperature, users can set cell properties for all cells in the domain or for a subset based on a polygon. Cell properties can be configured for all layers in the model or for a specific layer. Constant values, scattered point data, and vertical profiles can all be used to set the initial die concentration. Interpolation between sparse points can be customized using the interpolation options. Spatially varying initial conditions can be configured for all die classes at the same time or only for specific die classes. Boundary conditions for die must be configured using either a constant value or time series. Time series can be added from the die module settings. The time series for die concentration can be configured using the Boundary Data Series Editor for die. Each series can include concentration for each class defined in the die module. Concentrations can also be set for each layer. To complete the setup of the die module, time series data must be linked to a model boundary condition. The boundary group concentration frame can be used to complete the linkage between the flow boundary and a die concentration time series. To complete the setup of the die module, time series data must be linked to a model boundary condition. Now that the boundary condition has been linked to the time series of dye concentrations, we can save and run the model. Thank you for watching. You can find the link to the next video below.